But we can look at series now in geometric sequence or series. Geometric sequence, geometric series, geometric series. So let's quickly look at geometric series and see what we can get from there. I have few examples as well. I have few examples as well that we can quickly go through. This will be my first example. Let's look at this one. The summation of k is equal to 1 to 20 for 1 over 2 to the power k. So let's say we want to find what is our k, or let's say we want to expand this, and then in this case we'll try to look at our first 3 terms as well. So that will be 1 over 2, and then this would be 1 over 2 into squared 1 over 2 to the power 3, etc. So this is nothing but 1 over 2 into 1 over 4 into 1 over 8. So you see, this is no longer an arithmetic sequence, but this is geometric sequence. So the difference now, you need to say this is term 1, this is term 2, this is term 3, right? So you see, if you're saying term 2 divided by term 1, that would be 1 over 4 all over 1 over 2. This shall give us, because we're looking at 1 over 4 divided by 1, divided by 1 divided by 2. Okay, so it's 1 over 2 as well. So this is 1 over 2. Same thing, if you're saying 1 over 8 divided by 1 over 4, this is the same as 1 over 2. So now we're no longer having a different, but now what we're having is a ratio, a common ratio. So in a common ratio, or a general formula to calculate the summation, or the summation of a geometric sequence, will be Sn equal to let me just check quickly. So it's Sn equal to A into R to the power n minus 1 all over R minus 1. Okay, so you see from this example that we're looking at here, that means our first term will be 1 over 2, our first term. So we have 1 over 2 into our ratio is 1 over 2 as well, 1 over 2. Then our n is 20, 1 over 2 is to 20, 1 over 2 is to 20 minus 1 all over half minus 1. So you just put this in the calculator. Let's see what you get. 1 divided by 2 to the power 20 minus 1. So the answer will be 0.99999. Okay, so that is how we're finding the geometric series, the summation of it. So we're using the sigma notation, so that is what we will find. Okay, let's try to see if you can get another example that is a geometric sequence, and see if you can work on it. Trying to find something that is also a geometric sequence. Okay, let's try this one, though it's a little bit complicated. Let's try this one. So we have summation of k equal to 1, let's say to 20, and then we have 6 into 2 k. Okay, let's try first terms. Our first terms will be 12. We'll have 12, and then 6 times 4, and then we have 24, I think, because we have 8 times 6, we have 48. So you can still then look at the ratio, divide by 24. So our ratio here should be 2, because if you say 24 divided by 12 is 2, 48 divided by 24 is 2, so our ratio is 2. Our R is equal to 2 and our A is equal to 12. We just put it in the equation. A R to the power n minus 1 into R minus 1. This is 12 into 2 to the power 20 minus 1 all over 1, because it's just 2. Our R is 2, so it's 2 minus 1. So we have 2 to the power 20, 2 to the power 20 minus 1, minus 1 times 12 times 12. So that is what we'll get. We're getting 12, 58, 29, 0, 0. That will be our sum. So that is how we handle the arithmetic sequence. We can be given the same way. We can be given the summation, and we will have to find the number of terms in the series or in the sequence. We will apply the same way using the general formula, then we solve for n. Thank you so much for watching.